record the lesson. Okay, good. So, are you having your holiday? Yes. All right. Okay, good. Okay, let me connect my writing pad first. Okay, so you're learning it. I'm learning what? I'm learning my holiday. No, cannot be because I only take 2 hours, 2 hours of your time on Saturday. And then of course my homework is only like what, an hour. So only 3 hours every week from you. Okay, if I don't give you lessons, right, your mom will think of giving you some other activities as well. Okay, if you look at this, okay, so let me annotate now. Annotate, draw. Good. Okay, can you see your work here? Okay, so you have yes, very good. You have 140 here, and then what you need to do, you need to write 140 as the product of its prime factors. So this is prime factorization, the concept of prime factorization. So I see 7, which is a prime factor, which is prime number as well. So 2 and then 2 and then 5. Yes. So if you write it in this prime factorization manner, this is correct. Okay. And in fact, it's very good to see that you use this index notation. Remember that? This is called index notation. Okay. Very good. Next, 720. The 9 is not a prime fact. 9 is not a prime number. Why? Why is not?
Because it can be multiplied by 3.
Yes, you can actually split 9 to 3 and 3. So in fact, at the start of our previous lesson, I have already told you to remember the first few prime numbers. So the first prime number is 2, and then next is 3, and it's 5 and 7, and then 11. Okay, so these are the first 5 prime numbers. Okay, so basically if you get questions like this, okay, which tests you the concept of prime factorization, all you need to do is make use of one of the two. Okay, so your answer here is not correct. In fact, you can actually split, yes, so you need to split the 9 into 3 to the power of 2.
Oh.
All right. Yep. So remember that. Okay. Next, question 3. Expressed as a product with prime factor. Okay, 60 is very easy. So this is 5, right? Okay. This is 2 to the power 5. 2 to the power 5 is 32. Okay, good. So prime factorization of 60 is correct. Prime factorization of 96 is correct. Very good. So this is the way. Okay. Next one. So remember, 9 is not a prime factor. Next. I need to clear this. Good. Okay, we are at the next question. So over here, what they ask you? They say find the highest common factor of 60. Good. So over here, the question says, what is the highest common factor? So can you remember the definition of highest common factor? Two steps. So step 1 must be shared. Right?
1, find the common prime number. Step 2, find the lowest power for the prime numbers.
Correct. Very good. Lowest power, right? Oh, good. That means you have memorized it. Nice. So I see that both have 2. Okay, I pick out 2 first. And then I see both have 3. Okay, I pick 3 first. And then the lowest power for 2 is 2 here. Can you see? So I put 2 here. Lowest power for 3 is 1. Okay, so that means this is the one. So if you don't write this answer in prime factorization, then you write it in, like, you just write out the answer, which is 2 times 2 is 4, 4 times 3 is 12. So the answer is 12. Okay, so if you don't write index notation, because the question never asks you to write in index notation, you have to write it in the answer itself. Okay, so the answer is 12. Step 1 must be shared. Okay, and then of course must be lowest power. And then over here, all the prime number highest power for the prime. Very good. So this is the definition. Okay, so how we do it? How I will do it? Okay, I don't look at it. Okay, of course, you can do it this way, but this way is too slow. Right?
Wow.
Very slow. Okay, so I will just pick all the prime numbers available. I see 2, I see 3, and I see 5. Then I need to pick the highest power for each of them. So the highest power for 2 is 5 instead of 2. The highest power is 1. Okay, it's done. So basically you have 32 times 15. Can you help me out? 32 times 15. Can you help me double check whether the answer is 480? 32 times 15.
$480.
Okay, good. So that means the answer is 480. So this is, I will say this is method 2, which is so much faster, and I don't think you will make mistake if you remember the definition. Okay. By the way, where did you get the definition from just now? Is it from your brain, from your memory, or you just get it from somewhere else you have noted down? Okay, you have noted down the definitions and all the notes, which is very good. Okay, so you are not only a step ahead of your cohort, you are a few steps ahead already. Okay, very good. So this is method 1. Again, I think you are not going to use method 1 in the future because it's too slow already. It's for the primary 6, primary 5 students. Okay, you have progressed to secondary 1, so
But I'm primary 6.
no.
You say it's for primary 6 and primary 5 students. I'm primary
Yeah.
6 one.
Yeah, but you are a few steps ahead of your cohort, so you have learned this method also, method 2. So why not use the easier method, right? And by the way, you have already finished your primary 6 materials, right? So you have proceeded to beyond. I call you P6B already. B means beyond.
So we haven't finished our P6 topics yet.
No, P6 topics, we will talk about it. Oh, no. Your P6 last chapters, it will be covered in 4.0 later on. You will see. All right. In fact, I follow the syllabus very closely. So in fact, the intro assignment, like the second assignment, okay, is an intro to our new lesson. Okay. Next, express 120 as the product of power of its prime factors. So this is basically what they want you to do is index notation. This is another way to talk. This is another way to tell you to, please express the prime factors in index notation. So, okay, I see all the prime factors. I see three twos, and then okay, one. Okay, good. So find the lowest common multiple of 120 and 150. Okay, so in fact, you can do it this way, which is method 1. But of course, the easier way to do it is express 150 as the as its prime factorization in index notation, and then just follow the definition, right? All the prime factors available or present, and then choose the highest power for each prime factor. So in fact, this is also another way So you just pick 600, 600. Okay, so 600 is the answer. So you need to answer like the LCM equal to 600. Okay, very good. So you answer correctly for question 4. Okay, of course, here and there you have some minor mistake like this. There is some minor mistake here. Okay, next. Let me clear this first. Okay, good. 108.
Question 5A is wrong
How do you know? I haven't marked yet.
because I wrote 9 instead of 3 square.
Okay, good. So yeah, so once again, so 9 is not a prime number yet, so you need to continue to.
Wait, what does yet mean?
Yet means not finished.
Might be in the future.
No, if I tell you I have not eaten my lunch yet, that means it's just an additional yet, no? YET. Have you learned this before? Yeah, so it's like I have not yet, not yet. Like let's say I ask you, have you eaten your lunch? Let's say you have not eaten, then you say not yet. So not yet means at the moment, no, but I'm going to do it, after that. Not yes, yet. Okay, good. Anyway, so yeah, 9 once again is not a prime number, so you need to continue. You need to continue the prime factorization of it. Okay, so that's why this is the one. Okay, highest common factor of 108 and 24. Okay, so 108 is here. They ask you for 108, you go and do 180. Okay, so what is this? Okay, so you do 108 or you do 180? Okay, so never mind. So basically, the question is 108, but you go and do 180. Okay, so so this is wrong, huh? So in a way, like you make careless mistake. Okay, once again. Okay, so for question 5, okay, let's talk about 6, because question 5 you already copied the question wrongly, so your answer is definitely wrong. Okay, let's look at 6. Okay, 24 and 64. So for 24 and 64, right? Okay, so okay, before you write down the answer, the first step you should do is to write down the prime factorization for these two numbers. So for 24, right, you have 3 times 2 to the power of 3. And then for this, you have 2 to the power of 6. Okay. Maybe I should use a different color. Okay. So for 24, the prime factorization is this.
But is question correct?
Question 5 or question 6?
5.
Question 5, okay, because the question asks you to do 10. Yeah, okay. The question asks you to do 108. So 108 means you need to this prime factorization is wrong already. So for 108, what you need to do, same thing. You need to change your 108 to 108. You need to change to the, let's say it's 2. Then you have 54. Then you have 2 again.
2 square and 3 cube.
3 cube. Okay, good. Okay, 2 square. Yeah, good. So let me just write it down and help you check. Okay, and then 24 is 2 to the power 3 and then times 3. So you just highest common factor, shared and lowest. Shared and lowest, so shared 2 and 3 both shared. Lowest power for 2 is 2. Lowest power for 3 is 1. So the means is, yeah, 12, correct. Okay, 12 is correct. Okay, good. So for highest common factor of 24 and 64, right? So must be shared and lowest. Shared, I only see 2 is shared. And then the lowest power for 2 is 3. So the answer is 8, correct. So lowest common multiple, so must be all present prime numbers. I see 2, I see 3. Okay, so 2, the highest power is 6. So 3 times 64 is correct, 192. Where do you get all these answers from? I think the answers are provided right at the end of the.
No,
No. Oh, okay. I don't know. Actually, I don't
I
know.
do on my calculator.
Okay, good.
And then I got too lazy to write down.
But anyway, I'm not sure if the answers are provided. Okay, but anyway, it's okay. So for this, this and this, so the same thing lah. Instead of writing this down, writing the answer down, I think you should do the prime factorization first. Oh, because once you do the prime factorization, is very simple already. So this is 3 times 5 to the power 2, I guess. This is 3 times 5 times, is it 6 or 2 to the 3 to the power 3 to the power 2, yes. Then times 5 times 2, yes. And then for the highest common factor, so must be share. I see 3 and 5. The lowest power for 3 is 1. The lowest power for 5 is 1. Yeah. So if you multiply this, you get 15. So all prime numbers available. Highest power. So this, you have 15, 25, 50, 50 times this. Yeah, good. 450. Correct. Okay. Nice. Okay. So accept this. Accept that you copy the question wrongly and you end up with the wrong answers. The rest, basically the concept is there, which is good. Okay. So you are a few steps ahead of your cohort. Good to see. Next. How come it becomes this color already? Oh, okay, good. So another way I want to comment on your homework is because instead of sending me photos, what I would like you to do is you can actually use an app, then just consolidate all the photos together, so it's easier for me to mark or present in a PDF format. Okay, so please switch to that one, or if you are allowed, then you can use your Apple Pencil. Yeah. All right. So once again, this is this one is correct. Very, very simple already. Okay, correct. Then 35 you can break to, this is 35, the prime factorization. So if you choose the highest common factor, so I see 7 shared only, yes. So 56 as a product of, okay, this is good. This is 98. How come 98 is not given? So you need to do it yourself. 98 is what? 2. Then you get 49, then 7 squared. So between this and this, so you choose all prime numbers available, highest power. So you have 14 times. Are you correct or not? Are you correct? Oh, this is 49. I'm so sorry. So 8 times this. Okay, correct. Okay. So 84 and 180. Okay, so this. So once again, you need to do the prime factorization. Okay, without the prime factorization, I think it's very hard to tell. Right? It's very hard to tell, right? Without the prime factorization. I also cannot tell. Just look. I mean, just look at it. I cannot tell what's the highest common factor. Okay.
I use my calculator.
Yeah, of course you can use calculator, but I think it's a good practice to write down the prime factorization for these two, and then of course you just pick. Okay. Because you cannot always test. Okay. All right. Not try and error, you know, that kind of thing. Okay, next page. Okay, yeah, last page. In fact, for this question, I want to look at the question itself. Okay, let me stop share. Let me go to the question itself because I find that this question is very interesting. Sharing folder. Then using set one. I have not shared my screen yet, so don't worry. Yeah. Now I'm opening PDF. Yeah, I'm going to share the PDF. Can you see the PDF? Yeah, this is the one, 12. So the reason I give you question 12 is I want you to see that is relevant in our daily life. Okay. Let me just write it. Okay, find the lowest common multiple. Okay, this one is super easy. Just do the prime factorization. Right. So you just have 2 to the power of 3, then times 3. In fact, once you get the prime factorization, you can use your calculator and double check whether your this is correct or not. There is no answer at the last page. Yeah, yes, I agree with you. So good. So there is no answer. So you have to find answers yourself. But it's always a good practice to write down the prime factorization because once you have that, then you just, okay. Okay, by the way, I was talking about you can use a calculator. So you use a calculator to help you double check your prime factorization, whether your prime factorization is correct or not. If your prime factorization is wrong, of course your B will be wrong. Yeah, good. So this will be 6 times 6. So will be 2 to the power 2, then times 3 to the power 2. Let me double check. Okay, good. So with this, right, then over here it says what? James thinks of two numbers. The highest common factor of my two numbers is 3. So what this means? Highest common factor. So what's the definition of, how do you find HCF? HCF must be shared, right? And then lowest power. So what this means is, based on this, right? Based on this information, based on this first statement, right? So you know that this number X and number Y, right? They both have 3. And the lowest power for 3 is 1. So, okay lah. So that means you already get one factor for X. I mean, you already get one of the factors for X and Y based on this statement 1. Okay. And given the definition for highest common factor, because it must be shared, and then it must be lowest power, right? So yeah, so they both have 3, and the lowest power for 3 is 1. And by the way, when I say the lowest power is 1, so that means X for the first number, it can be 3 to the power of 3. But I don't know yet. So I just assume that one of them is 3 to the power 1. I don't know which one, but I will know after reading the second statement, which is here. So you see the lowest common multiple of my two numbers 45. So for this 45, I hope you can see 45 is, if you split into prime factorization, is 5 and then 3 to the power of 2. Right? Right. So with this, so what is the definition for LCM, lowest common multiple? It must be all prime numbers, right? And then highest power. Good. So that means you know that it must be 3 to the power of 2. So it means one of these must be 3 to the power of 2. So let me pick X to be 3 to the power of 2. Okay. And then one of them has a 5. Okay. One of them has a 5. Okay. So write down two numbers that James could be thinking of. Actually, there are a lot of possibilities here. Let me tell you why. So it can be 45. And then it can be 3 here. So basically 45 and 3. Or another possibility is this. So instead of the 5, I put the 5 here, I can put the 5 here. So if you put the 5 here, right, you will end up with what? You will end up with 15 and then you end up with 9. So basically you have 15 and 9.
That's my answer.
Yeah. Okay. So in fact, for this question, I'm trying to give you like I say, there is no fixed answers. Okay. There are different possibilities. Okay. There are different possibilities here. So this is also something, right? When you progress to Sec 1, you need to know that sometimes, okay, there is no fixed answer for that question. Okay. There are other possibilities. Okay. So something like our world. Okay. So it's not like, oh, long hair must be females and then short hair must be male, you know, that kind of thing. There are other possibilities. Right? By the way, one of my students, right, he has longer hair than you, and he is a boy. All right. So just to let you know, there are other possibilities. All right. So yeah, we have finished this. So okay. After looking at your answers for
the second one.
Pardon?
The one that doesn't make any sense.
Yeah,
at
okay,
all.
good. Yeah, good. So after looking at your answers for this assignment 1, right? I feel that you have a good grasp of this topic of prime factorization and of course HCF and then LCF. Okay. But of course you need to memorize. You need to memorize what? You need to memorize the definition. Okay. How you can find the HCF and LCF and how is it applicable to our life? Okay, we talked about it. Okay, last week. All right, so let me switch to our today's materials. This is homework 2. Homework 2. Okay, let me share it first. I have not shared yet. Let me share the PDF. Okay, can you see the PDF? All right, so okay, good. I think you can see already. So in fact, right, last lesson, I think we briefly talked about negative numbers, integers, and rational numbers, what real number and therefore operations. So in fact, today, here you look at some of the questions that you will encounter if you study them further. Okay. Not only this, actually, I have a very good photo which gives you a summary of all this. Let me send to this MacBook first. All right, good. All right, so can I ask you, before we talk about this 1.3, let me ask you. So let's talk about, okay, let's imagine this is our universe. Oh, by the way, these days they like to talk about the metaverse. Do you know what is a metaverse? You don't know metaverse? Okay, good. So gives you some this is called common knowledge. Okay, metaverse. So the spelling is this. So right now we are doing Zoom, right? Okay. So this is we are doing Zoom, right? So the spelling is this metaverse. Okay. In this metaverse, we use our avatar. You know the avatar? That means a cartoon representation of ourselves. Hello? A cartoon representation of ourselves. So in this metaverse, right, basically you can have a avatar and then you have a digital self. And then you just live your digital life in this metaverse. So right now we are having our we are living our real life, right? Okay. So imagine our real life now is digitized into the metaverse. So next time you are going to have fun in the digital world. You can buy gifts, something like the game, something like your game, yeah, something like your these games. So basically you can explore. So you can have your avatar, then you have your digital goods, you can buy clothes, you can buy all those things in the metaverse. So those are called digital goods. Okay, but today we are not talking about the metaverse. Today we want to talk about the universe. What is Gen Z impact? I don't know what's Gen Z impact. What is Gen Z impact? I cannot understand you. I don't understand your English. Game. So soon you I think you already live your digital life already. But next time it's going to be 3D, and then you can move. While you move, then instead of console, right? You move your hands, you move your heads, then basically your avatar, your digital self will move. Okay, good. So let's talk about universe. So in this math universe,
Math, drugs.
Math universe. So you have, okay, let's not talk about math first. Okay, I just want to talk about our normal human being. So in our human beings universe, right? So everything inside, right? If we talk about we talk about people first. Okay. So within this people universe, right? So what do you have? You have adults and children, right? So let's continue. You have adults. And then you also have children. So within adults and children, you have male and female. Of course, you can categorize as elderly, middle-aged people, and then all sorts. But I would like to categorize them as into genders first. You have male and female. Then for children, you have boy and girl, right? Okay. So that's how you can actually. Oh, so in fact, if I ask you which category children falls into, or which category girl falls into, then you will tell me, oh, girl falls into the children category. Yeah. So female falls into the adults category. So this is our very simple representation of the human beings universe. All right. So now, given this understanding, then we will look at the mathematics universe. Then you will start to understand what all the real numbers, rational number, whatever it is. So you have this mathematics universe. So in this universe, right? Okay, in this universe, we call it real numbers. Okay, so just like just now, in the human beings universe, people start first. Then after that, within people, you have adults and children. So within these real numbers, right? Okay, pay attention. Within real numbers, you have both rational numbers. You can divide it. You have real numbers. And then you have, of course, called unreal. Oh, no. You have rational numbers. Where do you get this from? Where do you get these circles from? Huh? Yeah, lah, you tell me where you get it from.
Book.
Which book? Wow. Wow. Where you get this book from?
My mom.
Okay, never mind. Good that you learn ahead. Okay, it's okay, but just pay a simple, okay, just pay attention to my way of explaining it. Okay, so you have the rational numbers on the left, and then you have the irrational numbers on the right. Okay, so some examples of irrational numbers is like square root 17. Can you use a calculator? Square root 17. What do you get?
4.123105626.
Yes. So this is what I call 2.222222222. That means this is indefinite. Okay, you don't get a definite answer. All right. So therefore, if you cannot get a definite answer, then you need to use irrational numbers to represent that number. Okay. So there is a place for irrational numbers to exist. Okay. So you can test another one, negative square root 11. So you will get negative something, I don't know. Can you help me out? Square negative, then square root 11, this one. Then you will get negative something.
Negative 3.31662479.
Okay. So in fact, right, the capability of your calculator is 9 digits. So you need to be aware of that. So your calculator cannot give you more than 9 digits. So in fact, right, for answers that do not have a definite answer, right, you need to have irrational numbers. So you need to have irrational numbers to represent them. So that's why you need to have irrational numbers, okay, which you have not encountered in P6. So when you ask me, hey, some of the questions they don't make sense. Okay, okay, of course, for answers that don't make sense, right, they fall into the irrational numbers universe. All right. Then of course, when it comes to rational numbers, okay, when it comes to rational numbers, so for rational numbers, they are finite. They are finite, like 0.3. Okay, like 0.3, which you can find out the answers. Like this, you can use fraction. You can use fraction to represent, right? You can use fraction to represent. And then of course, you have all the others. And then after that, inside these rational numbers, you will have what? You will, inside this rational number universe, you have integers. That's called integers. And then, yeah, then after that, integers, then you have whole numbers.
And then natural number.
Yeah, whole numbers. Oh, in fact, I'm not too sure about the natural numbers because I think there are too many names around already. I just want to stick to the ones that I'm familiar with. So real numbers, okay, real numbers, and then you split the real numbers into rational numbers and irrational numbers. Okay, irrational numbers, they exist for a reason. Okay, it's for you to represent
human beings.
So it's for you to represent some indefinite answers. Okay, answers like 3.222222222, you know, that kind of yeah, number. So you don't have to tell me, oh, this answer doesn't make sense. Okay, and then for the rational number side, then you have integers and then whole numbers. Okay, so with this basic understanding, then we can tackle this question already. So for this question, I think you will get 16 plus 36, which is square root 52. So what do you think? Do you want to use your calculator and calculate, and in the end you will get an indefinite answer?
Because it doesn't work.
No, it works, but it will not give you a definite answer. So basically,
no, it doesn't work. Let me show you.
So you will get an indefinite answer.
Math error.
No lah, square root 52 eh.
Yeah.
Square root 52, it gives you math error, cannot be what? Let me use my calculator. 不可能啊. I mean square root 52 eh, first question eh.
Square root 52. Oh.
Yeah. Yeah, indefinite answer, right?
111102551.
Yeah, so you will get an indefinite answer. So like I say, instead of having an indefinite answer, so that you need to use an irrational number to represent your answer. So your answer is square root 52. Okay, and square root 52 is a irrational number, opposite to rational number. Does it make sense to you now? Okay, good. So for the second one, I think you will get error. You know why? You know why you get error? Because you square root negative 20. In fact, when you square root negative number, right, you will get math error. You can test square root -1. You can test square root -12. All are math error. You test. Yep. So this is something like what? Okay. In your primary school career, I think you know that you cannot divide by 0, right? Cannot, right? 2 divided by 0, that means the 0 can never be the denominator. So same thing. When you progress to secondary 1, you cannot square root a negative number. So remember, you cannot square root a negative number. So remember this. Okay, remember this. You cannot square root a negative number. Okay, square root negative number, you will get error. Okay, then of course the last one will be 5. Okay, so for these three questions, you raise hand for what?
I need to go toilet.
Oh, then quick one. Yeah, quick. I'll give you a minute or two. Yeah. Welcome back. Okay, so with these two questions, right, then you get to see what? You get to see that you can use irrational numbers, which you can use your irrational number as an answer. And then you know that you cannot square root a negative number. For the last one, you get an answer 5. Okay, so good exercise. Okay, over here. Over here, they ask you what is the value of a. Let me look at your answer. It's in your it's in my WeChat. What's your answer for this? Your answer is no answer. Doesn't make sense. Okay, so now you realize that it makes sense, right? What's the answer?
5.
Here.
For question 3.
So this one is okay, let me continue. So you have 4, and then you have what? You have 8, 64. So you have a squared equals to 62 by 60. So you just have a equals to square root 60. In fact, you have plus and minus. So your answer is plus square root 60, and then or minus square root 60. That's your answer. Okay, so I hope you know that negative square root 60 is different from square root negative 60. You cannot do this. Square root negative number is not allowed. But negative then square root is allowed. I hope you see the difference. Huh? Can you see the difference or not? Negative square root is okay. Square root negative is not allowed. So negative square root 60, positive square root 60, they are both allowed because these two are what? Irrational number. So you can use irrational numbers to represent A. Can? So when your answer it says doesn't make sense, so it makes sense. But you need to use irrational numbers to represent. Okay. Then for the below question, did you use calculator to do these two questions?
Yes.
Okay. In fact, you are not supposed to. The reason is let me close this first. Okay. Why I say you are not supposed to? Because in the exam, right? Most likely this I will share after reopening the PDF. All right. Okay. You are not supposed to use a calculator because during the exam, right? Most likely this kind of question is paper 1. So paper 1, you're not allowed to use calculator. So how do you do it if you're not allowed to use calculator? So for addition of fraction, first step, you need to change to common denominator. That's the reason why you need to learn LCM, lowest common multiple. You understand now? Why you need to learn LCM? So for 3 and 7, right, the lowest common multiple is 21. Then you know that, oh, I need to times 7. Both denominator and numerator. So same thing. You times 3, then of course this times 3. Then you will end up with 49, and then 21, then plus 6, 21. And then of course, you then add the fraction together, denominator remain the same, and then 55. Oh, by the way, I need to caution you. Some students, they add the denominator as well. They say, oh, no, you can't. You can't.
do it.
Yeah, you can't. For addition, you cannot. For subtraction, you also cannot. So therefore, you just, this is an improper fraction. Okay, this is improper fraction. You need to convert into proper fraction. So if you use your calculator, you will get this. All right. That's why this is the answer. But if you're not allowed to use a calculator, so these are all the steps. Okay, so that's the reason why you need to learn LCM without you realizing it last time. Then over here, once again, LCM is 15. So therefore you have 4 times 3, 5 times 3, and 7 times 5. Of course, you have 3 times 5. Then you have 12 over 15. Then you have 35 over 15. Then you have minus 23, 15. Yeah, of course, minus 1. I think 8 over 15. Yeah, good. Okay, so these are the steps. Okay, so in fact, LCM concept is used while you do the addition and subtraction of fractions. All right. Oh, by the way, let me give you another question. What if how come I have, oh, okay, never mind. This is repeated, can you see? By the way, last time I give my student this question. Okay, last time I give my student this question. Okay, my student did not learn the concept of LCM. Hello, my student did not learn the concept of LCM. You know what my student did last time? He said, oh, this is 2, this is 8. Okay, simple. I just use 2 times 8 and then 1 times 8 and then plus 1 times 2, 8 times 2. Is this correct or not? Why not correct? Why correct?
Because you can do 2 times 4.
Okay. But
and
like
you don't change the 8. Just do this. And then this. Leave the poor 8 alone. And
good.
then
Good. Yep. Good. So it's 8, 5 over 8. Right? Okay, good. So when you do it your way, right? You are actually using the concept of LCM. But like I say, my student did not learn the concept of LCM. That's why my student just continue to do this. So let me continue my students the working here. So what you have is 8 over 16. And then you have 2 over 16. And then you have 10 over 16. And then after that, you divide by 2, 5, divide by 2, 8. So the answer is 5 over 8 as well. Hello? The answer is also 5 over 8. Compared to your answer, 5 over 8.
But she just simplified.
Yep. So
her way takes more time. My way
correct. Correct.
Time.
So you kind of understand if you know the concept of LCM, right? You just need to do this. And once you do this, and then you can get the answer very fast. Okay? You can get the answers very fast. But if you don't know the concept of LCM, can you stop? If you don't know the concept of LCM, right, then you have to go through all these steps. And then in the end, you still have to simplify. And you know, sometimes students forget to simplify. If you forget to simplify, then your answer is wrong, -1 mark. All right. So you see the benefits and the advantages of knowing more stuff. Okay, more knowledge. Okay, so that's why I feel that if you have started things earlier, then you will be a few steps ahead of your cohort. All right. Okay, I don't know why I repeat. I don't know why I repeat here again. Okay, but anyway,
I didn't do it because you repeated it, but I did this one.
So what do you think of this one?
I like the question.
Okay, first thing first, this question, you might not know what this question is, but
yes, but I like it a lot.
Just to share with you, this is called a quadratic equation. If you don't know, never mind, you encounter it soon. Just know that it's a quadratic equation. And then of course,
it equals to -21.
Your answer is?
-21.
I think 没有嘞. Oh, -21. Okay. I think you are wrong嘞. But never mind. Let's take a look at it together. So I write down your answer here first. So in fact, this question is nothing but just use a calculator. Okay. So over here, can you see that you have -b? Oh, by the way, over here you have plus and minus. Can you see plus and minus? Not only plus. Can you see the plus and minus here? Plus, minus. Can you see?
What the hell is plus minus?
Okay. So this is something I want to let you know also. When you have plus minus, right? So that means this whole thing, you can convert into two. You can convert into two possible answers. So one of them is this. Let me rewrite. So it's -b. Everything is the same except take the plus. Everything is the same. Okay, this is one possible answer. Then the other possible answer is everything is the same, but you take the minus. That's the meaning of this plus minus. So understand? Okay, good. So if you make use of, so they say A is equal to 1, B equals to 3, C equals to 2. So what you need to do, just replace your B with 3. So replace B with 3. Replace B with 3. Hold on. And then 4AC. 4AC means 4 times A times C. So A is 1. So I replace A with 1, C with 2. So I use a dot. And then A with 2. So by the way, this way of doing things is called substitution. Okay, you sub in all the values. So you sub in all the value. So let me not use the calculator yet. So just mental calculation first. So you are going to have -3 plus square root 9 minus 8. Then you have 4 below. I think your answer is wrong. -3 plus. So square root 1 is 1. And you have 4. And then you have -2 above. So one of the answer is half, -half. Okay. So one of the answer is -half. Okay, next. Below. Similarly, replace B with 3. Then the rest also with 3. Then 4 times 1 times 2. And then I have 2 times 1. Oh, I make a mistake here. A is 1, not 2. So it's not 4, it's 2. It's not 4, it's 2. It's not 4, it's 2. So that means the answer is 1, negative 1. The first answer is negative 1. Then of course, then you will get negative 3, negative 1, and then 2. So the answer is negative 2. Yeah. So you have negative 2 and negative 1. So far, so good.
Yes.
Hold on. Does it make sense? Let me see. 3 minus 1 minus 8 minus 1. Yeah, correct. Okay, correct. So yeah, so these are the two answers. So you shouldn't get negative 21. Let me see where you went wrong. You make a mistake here. Over here is times. You make a mistake here. So the way you write it is this. 9 minus 48. By the way, 9 minus 48, you cannot find an answer. You know why? Because you have negative minus 38. You cannot square root negative 38. You cannot square root a negative number, right? Am I right? Hello?
Yes.
So you're not supposed to square root a negative number. And by the way to look at this 4AC is 4 times A times C. So that's why you should do it the way I do here. Okay, so you should end up with a negative 1, and then of course you should end up with negative 2. That's the answer. Okay, this is just one way to solve this. Okay, can you use your calculator? Can you go to equation? Because last time you remember how you use a calculator to solve simultaneous equations, right? Can you remember that? You go to equation. Can you tell me which one of your this 1, 2, 3, 4 looks like this equation? Three, yes. Okay, so in fact, you just press 3. You press 3. You press 3, they will ask you to key in ABC. So your ABC is given here. You try to key in ABC. So A is 1, B is 3, C is 2. So you just press answer. So what do you get? So you get negative 1. Press one more time. I think you will get negative 2. You press equal one more time, you get negative 2. Test it out.
I did.
Yep. So you will get negative 1 and negative 2, right? Yeah. So you see, so in fact, your calculator is powerful enough to help you solve quadratic equations without going through this. Okay. There are two ways. There are two ways to find x in this case. So I've just shown you how you can do it with a formula, and then I have already asked you to test with your calculator. Okay. Before we proceed, let's take a brief 5-minute break, shall we?
Adios.
Yep. Good. So see you in 5 minutes. Yeah, welcome back. Let me know when you're back. Hello. So yep. So we just talk about how you can solve this x squared plus 3x plus 2 equals to 0. You can use method 1, which is this formula, and you can also use method 2. You have that capability in your calculator. All right, next. I don't see your answers for this question. Okay, representation and ordering of numbers on the number line. So this is a number line, and these are the numbers. I don't see you draw this, or at least label. Have man? You just arrange them only, but not in a number line, right?
What does that mean?
Oh, okay, good. So in fact, so that's why this is 1.5, which is chapter 1, and then 1.5, which is the topic. Right. So over here, you have a number line. This is called a number line. Okay. So let's talk about the general concept of a number line first, without looking at this question. Okay. So you have this is a line. Okay. This is a line with an arrow, and then you have a 0 here, and then on the left, you have the negative. You have the negative portion, the negative numbers portion, and then on the right, then you have the positive numbers portion. Okay, so this is the positive region, and then of course this is the negative region. So just beside 0, you have -1, and then if you continue, you have -2, and then you continue -3, and of course if you continue, there's no end to it. There is no end to it. All right, it can be -1,000, it can be -10,000, but we are not going to go so far. Okay, we will stop at -3. Okay, let's do for the positive region. So you have 1, you have 2, you have 3. You disappeared. Hello, are you around? All right, good. You're back. So yes, so 0 is the dividing, point. On the right of 0, you have the positive region. You have 1, 2, 3. Of course, you can go on and on, but we are not going to go on and on. Okay, we will stop at 3. So this is called a number line, given the labeling of numbers. So from a line, we have already transformed it into a number line. Okay, simple. So if we are given a few numbers, so let's say we are given this. Okay, let's say we are given this -2, 0, 1, and 1.5. So we need to put these numbers, all these numbers, into a number line. How we do it? Okay, so you don't need the -3. You need the -2 because you have a -2 here. So label the -2 here. You don't have a -1, so you don't have a -1. You don't need a -1 there, right? You have a 0, yes. So you need to label the 0 here. Okay, and then of course you have a 1, right? You don't need a 2, you don't need a 3 because you don't have a 2 and then you don't have a 3. But you have a 1.5. Where's your 1.5? In between 1 and 2. So just label here. Yeah. So in fact, you don't even need the dot here because they are not there. So this is called a number line, which represents this. Okay. You can also in fact, you don't need to give extra numbers because these are the numbers. You just have to represent these numbers. Okay, so for this question, so what you need to do is you need to arrange these numbers in a ascending order. What's the meaning of ascending order? Means small to big. That's your first job. Arrange them small to big first. So the smallest I think is -3. So you put -3 here first. And then the next smallest I think is -2/3. And then you have 3.14. What is this? Can you help me out? 22/7. What's the?
It's pi. It's
no,
pi.
No, pi is 3.1415 blah blah blah. But what is
yeah, 22/7, right? It's still it's also that.
It's close, but what is the 3 point? Is 3 point something?
It's also that.
So it's 3.1428. Okay, good. Thanks. 3.1428. Okay, good. So you will see, right? Actually, 22/7 is bigger than pi. Can you see or not? Compare. Can you see? It's bigger. It's pi, but it's bigger than pi. All right. So therefore, the next smallest is 3.14. And then the next smallest is pi. And then you have 22/7. Then you have 5.5. So first, you have already arranged all numbers in the ascending order. So with this, you can actually represent them in a number line already. So what I see -3, yeah, -3. So just roughly lah, huh? Later the no need one, then I just get rid of. Oh, looks like I need to extend this line a bit, because I have 5. I have 5.5 actually, not 5, 5.5. Okay, good. So with this number line, of course you need to use a ruler and then measure, and then measure the gap also. Okay, what I'm trying to say is you need to measure this gap. Make sure that all the gaps they are of the same length. All right. So over here, I'm not using a ruler. Okay, but you need to use a ruler. It must be straight line, and then of course the gaps must be the same throughout. Okay, so I need to write down the -3 first. Okay, good. -3 is here. This is -3. -2/3. So -2/3 I think is somewhere here. Because -2/3 is -0.666, continue. So it's somewhere here. And then you have the 3.14, which is here. And then you have the 3.1415, so which is very close, but not touching, which is pi. And then you have another one, 22/7. And then of course you have 5.5. Okay, so far so good. So it's advisable to use different colors so that it won't be red throughout. So it also looks very clear. Okay, easily identified by the marker. Okay, so this is how you represent the numbers on the number line. Okay, then yeah, good. So yeah, the use of this bigger, smaller, bigger, bigger and smaller, smaller and bigger signs. Okay, so let's look at it. So for this one, clearly 2 is smaller than 4, right? And for this once again is a rational number. Okay, this is a definite answer. Okay, so this is equivalent to 0.333333 non-stop. So this one has to be bigger than this. So far so good. Then for this -3 is smaller than -2. This is 0.25. So this is, yeah. Then you must be wondering, when do we use this? When do we use this sign? When?
I don't know. I've never learned it.
Okay, good. So let's talk about these two signs. So, I have this question. Did I give you that question here? 没有. Okay, let me get the question up. It's from my the other student, Shamin. Are you looking at this?
Yes.
Okay. Not this.
Isn't like this from one of the PSLEs, like these questions that you just showed me?
Which question? Like which question?
The questions that you just showed me, all of them. I think they're from past PSLEs.
Oh, okay. Some of them they might look similar lah. Because I also saw questions from PSLE papers and other PSLE papers also. So in a way, questions are similar in appearance. Okay, never mind. You just look at this. Okay, let's make use of this graph. Let me make use of this graph. Okay, I'm going to make use of this question. Okay, let's look at this question. How we can use so over here, the score for the quiz is shown below. So you have 2 ones. So this has been drawn for you already. So how many 2 you have? 1, 2. You have 2, 2. Okay, so 2. So similarly, you have 2, 2. Done. You have how many 3? 1, 2. Okay, you have 2, 3 as well. Done. You have how many 4? 1, 2, 3. You have 3, 4. So this is called a bar chart. So 5, 2, 5. Okay, good. I finished the bar chart already. Okay, good. So let's look at the question here. So the first question, it says the average of the score. Average is very simple. So it's just total divided by the number of students. Okay, which I'm not interested actually. In fact, what I'm interested is how can we make use of this sign, right? So what if the question asks, what is the percentage of students who score at least 2? How are you going to answer this question? So what is the percentage of students who score at least 2? So when you score, when they ask at least 2, is 2 included or not?
Yes.
So if 2 is included, right? So basically the way you do it is at least 2 means bigger than 2 and include the 2. That's why you put an equal sign there. So at least 2 means bigger than 2 and 2 is included.
Oh,
and
okay.
this is how you use this sign to represent at least 2. Does it make sense to you now? Yeah. So when you have the 2 is included, right, then you just have this equal sign there. So similarly, if you have at most 5. So at most 5 means smaller than 5. Is 5 included?
No.
Huh? Why not?
Wait,
At
yes,
most,
yes.
yeah, at most 5 ma. Yeah, that means the maximum you can go is 5. So that means the 5 is included. So that's why you make use of this sign. So this smaller and equal or bigger than equal, basically it says what? It says if you have the equal sign here, that means the 5 is included. Okay. If you have this, the 2 is also included. Okay. That's the meaning of this sign. That's how you can make use of these signs to represent expression like this. At most, at least, maximum, minimum, that kind of thing. Okay. So let's go back to our this. Yeah. So now you know how to make use of this, right? So if I write this, x is smaller or equal to 2. So the English meaning of this is x is smaller than 2. 2 is included. All right. Can? So if I give you a few numbers, I give you 0, 1, 1.5, 2, 3, 4. And I ask you, x is smaller than 2. So x is, so out of this, you need to pick 0, 1,
or 1.5.
5. Do you think 2 is included?
2. Yes.
Yes. So basically x can be, x can be 0, 1, 1.5, and 2. Okay. If the equal sign is not there, then your 2 cannot be there. Make sense? Make sense?
Yes.
That's how, that's the meaning of this sign with an equal sign. All right. So very simple. So we have covered 1.6. So last one, 1.7, approximation estimation. Okay, before you understand approximation and the approximation and estimation, right? Have you learned 2 significant figures and 2 decimal places? Have you learned all these concepts?
No.
No. I think you have learned 2 decimal places before because we talked about.
I've learned 2 decimal places, but I don't know 2 significant figures.
Okay, good. So let's talk about these concepts. What are 2 significant figures? What are 2 decimal places? Okay, let's go to a blank page. Okay, let's use this blank space. So 2 significant figures versus 2 decimal places. Okay, I will say the concepts are similar, but there is one difference between these 2. Let's talk about 2 decimal places because you are familiar with it. So if I have $2.9985, okay, so this is in dollars, so you have to convert it into 2 decimal places, right? So you convert to 2 decimal places. This is your first decimal place, this is your second decimal place, so therefore you need to convert to 2 decimal places. So you draw a line here, then you ask yourself whether this third decimal place is big enough for you to add 1 to the front digit. So in this case, yes, is more than 5 or 5. So that means this is the reason to add, whether you add up or round down, right? The requirement is whether it's bigger or equal to 5, right? So if it's bigger or equal to 5, you round up. If not, you round down. So we make use of this sign already. So in this case, is equal to 5? Yes, round up. So I add 1 into this. I add 1 into the second decimal place. So you will end up with 2.99. So this is 2 decimal places. Okay, so this is 2 decimal places. For 2 significant figures. Okay, pay attention. You can take down the notes after that, because you can watch this recorded video anytime you want. So for 2 significant figures, you need to know that the first significant figure, I'm going to use short form. The first significant figure is a non-zero number. Okay, that's it. The first significant figure is a non-zero number. So if I have 2.985, which one of this is my first significant figure? Given the definition, the first significant figure has to be a non-zero number. So is 2 my first significant figure? Is this the first? Yes, because it's non-zero. Yeah, 2 is the first significant figure because it's non-zero. Okay, so this is my first significant figure. So the second significant figure is here. This is my second significant figure. Then you want to round to 2 significant figure, then you just draw one line to separate. Then you ask yourself whether your this third significant figure, do you need to add 1 to it or not? Here is yes, because it's bigger than 5, bigger or equal to 5. So you need to add 1 to the second significant figure digit. So if you add 1, you realize the answer becomes 3.0. So this is two significant figure, 2SF. Okay, so far so good. Yep, so I'm going to give you some examples, which is this. So over here, I combine everything together already. Let me erase this first. Okay, before you do this question, right, you need to convert this 4.65, convert 1, 2, 3, 4. You need to convert the 0.0983, and you need to convert the 12.1. Convert them all into one significant figure first. Okay, you want to try it out first? You want to try it out? Convert 4.65, 1, 2, 3, 4, 0.0983, 12.1. And remember, the first significant figure is a non-zero number. Yeah, you continue first. By the way, one significant figure, not one decimal place, just to warn you. Okay, good. The last one. If you don't know the third one, it's okay. If you don't know the 0.0983, it's okay. Okay, are you done? Good. So basically, yeah, you have some difficulties. Okay, let's look at these 4 examples. Okay, so let me clear your drawing first. So, like I say, the first significant figure is a non-zero number. So I start with this. Is this my first? That's the question I ask myself. This is 4. Is non-zero. Yes, this is my first. So if this is my first, I draw a line. I ask myself, the second one, do I need to add 1 to the first? Yes, because it's bigger and equal to 5. So I need to add 1 to this. So if 4, you add 1 to it, you get 5. So that's it. So 4.65 to one significant figure is 5. Here, by the way, this is 1, 2, 3, 4, meaning this is 1,234. Okay, so I ask myself, is this my first significant figure? 1 is a non-zero number. Yes, this is my first. So I draw a line. And then I ask myself, do I need to add 1 to this? So to add 1, right, it must be more than 5. So 2 is smaller than 5. So I don't need to add 1. So I add 0. So that means I don't do anything. So 1. But this is 1,000 something. So how can you round to 1? 1,000, you round to one significant figure. You cannot round, you can round down or round up, but you cannot change the number so much. So you replace with 0. So you have 1,234. If you round to one significant figure, you have 1,000 left. Okay, you cannot, wow, you start with 1,000 plus, then you end up with 1. It's like 1,000 times smaller. You cannot. Okay, so you replace with 0. And here, is this my first significant figure? First significant figure is a non-zero number. Nope, it's 0. This is not my first. Is this my first? Nope, it's 0. So still no. Is this my first non-zero? I mean, this is my first significant figure. Yes, 9 is non-zero. So this is my first. So I draw a line. I ask myself, do I need to add 1 to this? Yes, I need to plus 1 here to this first significant figure. So if you add 1 to this, you will end up with 0.1. Does it make sense? In fact, it's 0.10 but you just need one significant figure, so the 0 is not needed. So the 0 can be ignored. One significant figure means what? This is not my first. This is my first. And that's it. I just need 1. So this answer is correct. 0.1 is the answer. So one significant figure. So for this, is this my first? Yes, it's non-zero. I draw a line. Add 1 or add 0. Smaller than 5. No need to add. So it's 1. So since you start with 12, so replace by 0. So it's 10. So this is 2, 1 significant figure. Okay, good. So after that, I have, so basically this entire question changed to 5 times 1,000, 0.1 times 10, 5,000, 1. The answer is 5,000. Much, much simpler. After using one significant figure, so this is the estimated answer to this. Okay, because sometimes, right, sometimes you don't need to know the exact value of this. You just want to roughly know. Yeah, very good. So with this understanding, can you proceed to do this by yourself on a piece of paper and tell me the answer? Over here, it says to 2 decimal places. Using 2 decimal places. Okay, can you proceed to do this question and then let me know the answer before I verify your answer later? Can you do it on a piece of paper first?
Is it 4.0? Yeah.
Okay, good. Never mind. Let me do it.
4.175. Okay.
I'm not sure. Let's do it together. So in the meantime, I can help you verify your answer. Let me see. Hold on. Let me switch to. Let me switch to PowerPoint. Sharing PowerPoint. Easier. I'm opening PowerPoint. I'm not sharing yet.
No.
Yep, I know. So let me share now. Okay, now here it is. Okay, so over here it says to 2 decimal places. And later on you will see, right, once you switch to 2 decimal places, you will realize the approximation is not so easy to figure out if you don't use a calculator. So to 2 decimal place, I write down first. So for 4.658 to 2 decimal place, so what I need to ask myself, this is not the first, because I need to go to the decimal point and behind it. This is my first, this is my second. I draw a line, so I need to add 1. Yes, so this will end up with 4.66. Next, 1.234. This is first, this is second. Add 1 or add 0, no need to add, so it's 1.23. Next, 0.0983. This is my first decimal place, second, so add 1, add 0, add 1, 0.10. Oh, by the way, in this case, it's 0.10, so it's 2 decimal place. Just now is 0.1. That one is 1 that's significant figure. So I just want you to see the difference between the two. This is 0.1, this is 0.10. By the way, 0.1 and 0.10 is the same. Mathematically, they are equal. What's the difference here? 0.1 is and 0.
There's 0 at the back.
Correct. Correct. The only difference is there is a 0 at the back. This 0 at the back is to fulfill the 2 decimal places. Can you skip the 0 or not? Let's say, oh, I don't want to write the 0. Can you?
Because it's not 2 decimal places anymore.
Correct. So you need to have a 0 to fill the gap here, or fill the place here. Okay. Without the 0 for 2 decimal places, you are wrong. Without the 0 for 2 decimal places, you are wrong. Because if without the 0, here is 1 decimal place. So you are wrong. But for 1 significant figure, it's okay. Because this is your first significant figure. So that's how you decide. All right. So this is something you need to be cautious. Next, then you have this 12.15. Okay, 12.15 is already 2 decimal places itself. So it's just 12.15. Okay, if you look at this, right, you will realize that without the calculator, if you go and do approximation, I think it's pretty hard, right? Am I right or not? Yeah, I don't think I can figure it out also without using a calculator. Okay, but anyway, so you are allowed to use a calculator, and then you just use your calculator and then compute this out. I think you should be able to get the answer. All right. So just write down
4.72 because I have to round up.
Do you need to round?
I think so, because no.
Okay, it's many. Okay, yeah. So you will see many numbers. So for this question, estimate the value below what round? Yeah, I think when they ask you to estimate, right? I think if you round to 2 decimal places, so the last answer should round to 2 decimal places as well. All right. Okay. So you will see that, you see, to use 1 significant figure, to use the 2 decimal places, you realize, right? Using 1 significant figure is easier for you to do approximation, right? Is much easier to do approximation. All right. So that's why this is also something you learn today. Okay. So we can actually use approximation by using let me share the PDF. So to use a significant figure is easier for approximation. to use two separate places, you still need to use a calculator, which is not so easy to do. All right. So this is the concept of approximation and estimation. All right. So yeah, you have learned significant figures already. And then, yeah, so let's take a look at the syllabus. Actually, I have added one more thing in your folder that I'm sharing with you. So in fact, you have seen this?
Yeah.
51 fun tech tools. You have seen it?
Yeah.
Okay, good. So these are very, very interesting tools you can make use of. Okay. You can add audio, you can add video, or you can just play with it. This one, I like it particularly, blob opera. So you just drag it, then you can create sound. Okay. So you can have some fun sound activities. All right. So I share it with you. So go ahead and play with it. It's much, much more interesting than your brother doing magic. Okay. All right. So explore this together with your brother. I find these resources very, very good. That's why I want to share with my student. So one of my students is you, so I just share with you. Okay, next, let's look at our syllabus. So where we are and where we are heading next. Okay, this is it. So far, we have completed this much. Okay, we have completed this already. Done already. Done already. Okay, so chapter 1, very easy, very basic. So you have a very good foundation. Forward. In fact, the next one will be ratio and proportion. I think for ratio, you have no problem. We have learned about ratio in the past, like P6, P5. Okay, but how is ratio related in our real life? We will talk about it in our next lesson. Okay, ratio and proportion. All right, so we still have a bit of time. In fact, I explore one of these, and I find it very interesting.
Blob opera.
Huh? I need to allow. I need to. No, I don't want to restore. Let me share my screen. Okay, let me share my screen first. How to stop share and then share my screen. Can you see my screen?
Blob opera.
Yep. So I launch experiment. It's loading. Can you hear the voice or not?
You try? I cannot.
You cannot?
Cannot.
You cannot? Okay. Let me show you how you can actually hear the sound. Hold on. Can you hear?
Yes, I heard it.
So you drag it. They just something like this. So you can play with it. Yeah?
So weird.
So you just keep. So you can even record it. You know. So after that, you record. So basically, you have a video to show to your friend and your mom. Then you have created this sound. You call this a sound experiment. You know. Then you can actually show off your music talent. All right. So I find it's pretty interesting for this one. Okay. This is a project by Google. So I think it's pretty good. You can actually take a tour here. You can actually use a different. You have a different backstage. Yeah, background. Yeah, like a stage. So you can actually just keep playing with it. Things like this. Very, very interesting. In fact, you should explore not only this, you should explore the 51 tools given. Okay, they are very, very fun stuff. And then adding sound to virtual meeting. This is also very interesting. So let's say if you score one thing, okay, let's say you have score let's say you score well, and then let's say you do the question correctly. I can actually play this. Clap for you, all this. Right? Then the timer, you say, oh, it's like, oh, you're wrong, then. Yeah, not good. Wrong, So you can add this sound to your PowerPoint. Do you need to create PowerPoint in your
We
school?
do.
Yeah,
We
so
do.
yep. So exactly. So in fact, you can actually add the sound to this one. Then when you present, then you can actually have, instead of
Sure, can I show you something?
Are you sure? Let me stop sharing. Go ahead.
Share screen.
You can share your screen.
Wait, not this one.
Are you using a MacBook? MacBook.
Yeah.
Okay.
I'm to show you something. This one.
You are not sharing yet, yeah?
I know. I know that.
Is this your new MacBook?
No. Oh.
Oh.
The same one. I can't open my PowerPoint. Oh, never mind.
In order to use PowerPoint, you need to purchase, I think.
No need.
No need. Okay.
It's just for some things we need to purchase.
Yeah. You're not sharing, just to let you know.
I know.
If you're not sharing, how to share? Yeah, okay. Okay, science project and then yeah, topic. Okay.
So boring.
Yeah lah.
How to add the sound?
Add sound lah. And then okay, wait. Okay, one thing I want you to add is add the sound, like the crack sound. You know how to add the sound or not?
No.
Yeah. Okay. You go to the frog slide first.
That's the end.
No, you go to the frog slide. No, not this one. Just not many frogs. Yes. Stop. So you go to insert. You go insert. No. Yeah. You go to insert. Can you see the? Hold on. Can you see audio? Last. Right. Yes.
This one.
Yes. Can you press audio? Insert audio, yeah. Press again. No, you need to go to the arrow. You need to go to audio, the arrow.
Audio.
Yes.
Right.
Yes.
And then there is the audio browser.
How come you are not allowed to add?
And there is the audio file.
Yeah, just so you need to add the audio file, which is you can download from that website.
Okay.
Okay. Another thing you can add is the video. You go to video. So probably just now you have already created your music experiment, right? You can also add those.
Movie browser.
Yeah. Understand? So there are many things you can add to this. If not, this is so boring, so wordy, so boring.
I like.
Okay. So since you are doing this PowerPoint slide, I give you one example which you can improve your PowerPoint so much. Okay, just give you some ideas. Can I share my one of my slide?
Yes.
I got this slide from let me see. Got it from. It's called Keynote. Can you see my screen? Can you see my screen now?
It's 14 hours.
Yes.
Okay, good. Let me go to let me do a search. Keynote. So just now the science PowerPoint is for what purpose?
Is our homework project.
Okay, so here's the one. Listen. No, this is not what I want to share. I don't know where I keep that already. But never mind. So next time if I have it, I will share with you. Okay, I will give some idea. So I will get it ready next time. So I will share with you in my next lesson. Because now I don't have it.
Then C is also right.
Yeah, never mind. So just say hi and then stay safe. Yeah. All right.
Okay.
Hey, any other question for me before we end the
No.
lesson? Okay, no, then please add sound, add a lot of sound, and then of course video to your PowerPoint slide to make it more interesting.
Okay, bye-bye.
Okay, take care. Bye bye.
Bye-bye.